Okay, so today we're going to be going over another A1398 Retina with no video. And this is the model that Apple recalled for the graphics chip issue, which means that we have to replace the graphics chip, right? Because it's always the graphics chip. It's always something that you got a heat gun or reball or reflow, because that's what a forum said. Or maybe it's a display cable. Every forum says it's always a display cable. Can it only be the display cable so the problem can be something that somebody else will fix for $5? And, you know, I am so sick and tired of reading these posts where it's the same shit over and over again, which is, let's not use our brain to figure out what's wrong. Rather, let's hope that it's either the cheapest thing there and come up with a bunch of wishful thinking bullshit as to why it's the cheapest thing, or let's just run for the heat gun because some video posted to YouTube 10 years ago about an HP showed it working after they did that. And it's all just a bunch of crap. So the first thing that I'm going to do here is see if the screen itself is actually getting power. So this is a different screen that was put on here. The original screen on this computer was cracked. It was replaced by the end user. After they replaced it, they went from having a cracked screen to having no screen. So let's just see if this is even getting power to turn on. So let's just look over the schematic here. Hey, I'm getting a phone call. There's like 2 people that have my personal cell phone number. How is this possible? Hello? 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 Oh, well. I have to set this shit to block private number. Private number is always bullshit. I have that blocked at the store. If you call with caller ID set to anonymous number or something, it just doesn't let the call through because it's always some call and hang up bullshit. Anyway, back to work here. So let's take a look at where the LCD is going to get power by going to that page on the schematic, and don't get too confused here. All right, check it out. Schematic, LCD panel interface. So J9000 is the LCD connector, and then you have a bunch of stuff over here. I know, confusing. What the fuck is all this DP, INT, PP, whatever the shit? Okay, let's try to make this simple. PPV out, LCD backlight. That's for backlight. We don't have a picture yet, so I'm ignoring that. LED return. LED return, that's going to be for the LED backlight. I'm ignoring this. I don't have that yet. LCD HPD. That actually kind of sounds like an STD. I'm ignoring that because that comes out from the LCD. I'm not interested in that yet. Here we go. DP for display port. Display port internal aux, display port internal, all this stuff. This may be important for if my image is corrupt or if I'm getting the screen's light is coming on, but I'm not getting a picture or something like that. Now let's go down here to what this is. So this over here is going to be power for the LCD. So here it says LCD power enable. Let's break this down because right now you think this is a bunch of confusing stuff that you can't understand because it's all abbreviated with tiny numbers and symbols and squiggly lines. LCD per N. Let's buy some vowels. LCD power enable. So when this signal comes in here, the LCD power will be turned on, like it says over here where it says on. V in, voltage in. Let's buy a word, voltage in. V out. Let's buy a word, voltage out. So now let's use common sense after buying all our vowels and words. When LCD power enable goes to the on pin, it's going to allow PP5VSO, which is 5 volts for the LCD, 5 volts, 5V for the LCD, to go to the input and then get shot out as 5 volts for the LCD, bunch of other crap that you don't need to know. Now, that's going to go over to this inductor, which in this case is being used as a fuse. If you don't know what the component is, honestly, just fucking gloss over it in the beginning. Just don't care. Just try to keep it as simple as possible. Try to understand the concept rather than understanding what every individual component does. I'm not saying that you shouldn't learn what an inductor does. I'm not saying that you shouldn't learn what a capacitor does. This is all very important stuff. But in the absolute beginning, if you're one of those people looking at this going, how the fuck should I get what any of this is? Just try to understand the overall concept, because when you understand the overall concept, everything else is just going to kind of flow into place. LCD power enable is going to turn this chip on. When this chip turns on, 5 volts for the LCD is going to go from the input to the output, and it's going to follow this little line where it's going to go to the LCD on pins 28, 29, and 30. It says over here, PP5V, which you can imply or assume means 5 volts. If you can't assume that, you can check where it says voltage equals 5 volts right under it, which confirms that it's 5 volts. And from there, we're going to measure. When we turn this thing on, what do we get on pins 28, 29, and 30? So I am going to look at that area. Let's just get it so you can see everything in here. So we have my multimeter on the table. I'm going to set it to voltage mode. We're going to set it to where there's a V. See the V? V for voltage, and then this is going to be DC voltage that we're measuring. Look at my video on AC versus DC voltage if you want to understand why it is that the screen runs off of DC voltage. I have a video in the Basic Electronics video series that explains what AC versus DC voltage is. You're going to set it to the little flat line of volts, on volts, and we're going to take the black probe and we're going to put it on ground, which is a screw hole or anything like that, and we're going to turn this thing on. And you tell me what I get. Let's see if you can even see it. So I'm going to take the black probe and I'm going to put it on a screw hole, the red probe here, and since I did that, I can't actually turn it on because I ran out of space. All right, here we go. Let's see. Can you see the voltage that I get? So I'm measuring right in that inductor. And I get 2.8 volts, 2.7 volts, 2.8 volts. So that's not good. Now let's check the other side of the inductor. The reason I'm checking the other side of the inductor is because I want to see where the voltage stops. Once I see where the voltage stops, I'll know that that's where I have to troubleshoot. And I was getting 2.8 volts on the other side of the inductor as well. So now let's go a little bit back in this schematic over here. So we have 2.8 volts here and 2.8 volts here. Now let's see what I have on V out of U8300. Again, what we want to do here is you want to see where the signal is stopping. So I'm just going to turn this off. I'm just going to unplug it. I have the SSD unplugged, so I don't have to worry about fucking up the operating system. And let's go to U8300. I'm going to do over here is... Actually, I'm in the wrong schematic, believe it or not. This is actually the wrong schematic. Imagine that. Let's open the proper schematic for this board. It's probably going to be the same shit. All right, see, it's the same shit. It's the same fucking layout. Don't be a troll and say that everything I said is irrelevant because I had the wrong schematic open. It's literally the exact same layout, except the inductor is labeled L9000 and the chip is labeled U9000. Big deal. So we hit C on the board view, and then we type in U9000, and it's going to bring me over to U9000. Well, it's not going to bring me over to it. It's actually going to move my entire board off of the screen because the software sucks, forcing me to find it, but it's going to highlight U9000. Now, let's see. On pins 4 and 5, what do I get? So on pins 4 and 5 over here, let's see what I get. We're going to find U9000. U9000 is over here. And we measure, and what do we get? So you get 4.82. So that's let me just turn it on and off again because I think the voltage is actually going up as I keep it plugged in. All right, so we're going to turn it on and off, and now I'm just going to measure at that point, at the moment that the machine turns on. And I'm getting 2.7 volts. Now let's see what I'm getting at input. So input of U9000 is 5 volts. So now I know that something inside of U9000 is keeping voltage from going through. Now the last thing to do before I blame U9000 is to check and see if this is actually being told to turn on. So as you can see on the schematic diagram over here, pin number 1 is going to be on, where LCD power enable comes in. And we need to have signal there. We need to have something there in order for this to work. And what I get on my multimeter is 3.3 volts at that point. So now I can logically determine that U9000 is why PP5ESO-LCD is not passing through and becoming PP5VR3V3_SW_LCD_iSense. So now I can logically conclude that I can replace U9000, and while I may not have an image at that point, at the very least I've solved one of my primary problems. See, no reflowing with a heat gun, no replacing screen cable. Just think. Now I have to find one of those boards in my crap pile. Aha! I found one that's not missing that component. That's rare. Oh, trust me. That is very rare. To actually find what I'm looking for in that pile. Turn on all the loud stuff. And now I'm going to turn the air down on my soldering station a little bit because that's very close to the LCD connector. So, and I'd like to not burn the plastic. I know that, I mean, who am I kidding? I am going to burn the plastic, but I'd like to try and not burn the plastic, if possible. So less air means it's not going to blow around the surrounding area as much, which means there's hope of me not burning the plastic. So what I did there is I got really close in on the chip, because the closer I am to the chip, the less the heat is distributed around the area of it, and the less likely I am to burn the LCD connector there. Yep. So it's in view, you can see everything. I should put this on the screen in front of me just so I can see without looking to the left. Okay, so we're going to just yoink. That's me soldering like an ape. I have to live up to the EEV block stereotype, as stated by Shock. I think I said this in one of the last videos, but I'm thinking of actually adding an ape to my logo next to the sheep. That would be pretty cool. Like in 2000, I've had the same logo for like for a really long time. I should switch it up. Now to piss off Oneness from YouTube, who says that I use unauthorized, uncertified, used parts pulled from other PCBs. There's this one jackass that was saying, you can't expect them to do component level repair because how are they going to stock parts for all of this shit? And the thing is, if I'm able to stock parts for all this shit, then why the fuck can't you? Like the same guy is criticizing that I use used stuff, right? Like a part that I pulled off of another motherboard. But that same guy is explaining how even a multi-billion-dollar company can't find it worthwhile to stock every single part that they need. Well, firstly, if I was a multi-billion-dollar company, yes, I would have spools filled with all these parts, which is totally impractical because there are used parts that you shouldn't use when they're used. Like, for example, there's a difference between buying a used car and buying, let's say, used underpants. One is used and it's commonly accepted that it's probably going to work, and one is used and just kind of disgusting. And again, I would not use a used graphics chip because as you put time on that graphics chip, it's going to be more and more likely to die every single time you use it, and you put in this little overheating, this awful environment. But something like this chip, that chip is going to outlive all of us. That chip is going to last a very long time. So I see no reason for it to be wrong that I use a used one, especially if it gives me the benefit of being able to give it back to the customer faster. It's not really a question of whether I do the repair slow or fast. It's a question of whether or not they leave it here at all. If I tell somebody, well, every time I need to test this to see what's wrong with it and get a component, it's going to take me a week, they're not going to leave anything here. They're just going to buy a new one. And but if I were a multi-billion-dollar company, yeah, I would have people on staff that did nothing but have deal with a huge wall of parts that was cataloged with like a little touchscreen thingy where I'd say I need this chip, and the bin would just come out automatically, and I'd be able to walk up to it. If I were Apple, I would do that. There's no reason why you can't do that as a multi-billion-dollar company. As you can see, the screen works, which means that fixed it. So it was U9000, which is what sends PP5E S4 over to, or PP5E SO, I honestly don't remember off the top of my head, over to the LCD when the PCH tells it to. Yeah, I do have a bin here of, common stuff, like the stuff that I regularly use. Because if I use it regularly, eventually I'm going to run out of it on the donor boards. But stuff like that I replace, twice a year or once a year, I just don't buy. And that's that. I hope you learned something.